Hello friends, today's question: a mass m attached to a spring oscillates with a time period of 2 seconds. If the mass is increased by 2 kg, the period increased by 1 second. Find the initial mass m assuming that Hooke's law is obeyed. So in this question, we are going to use the basic formula for the time period of our oscillation, and in that case the mass will be m and the time is given at 2 seconds. In the second case, the mass is increased by 2, so now it becomes m plus 2, and the time is increased by 1 second. It means the time period becomes 3 seconds. So we are having these two equations, and we are going to solve it and try to solve it for m. We have to find out the mass. So let's start with the time period of oscillation in SHM. We can write the time period of oscillation in SHM. It is given as t is equal to 2 pi square root of m divided by k, where t is the time period, m is the mass, and k is the spring constant. So we have two conditions now. Let us call when the mass is m as initial condition. So we write for initial condition, we are having that mass is equal to capital M, and the time period is given as initial time period. We assume it to be t1, and that is given as 2 seconds. Therefore, we can write that t1 is equal to 2 pi upon m upon k, and where this capital M is our initial mass. Okay, let me call this as initial mass, which is initial. So we substitute value of t1, that is 2, so this becomes 2 pi square root of m upon k. 2 cancel with 2, and we are left with we can write this as square root of m upon k is equal to 1 upon pi. So therefore we can write that our m is equal to our k upon pi square. Let us call it question number 1. And that second condition, when the mass is increased by 2 kg, let us call that as a final condition. So we have final condition, mass is now equal to capital M plus 2 kg, and final time period, let us suppose that is t2, that will be equal to 3 seconds. Final time period is t2, and that is increased by 1 second, so this will be 2 plus 1, and we have 3 seconds. Therefore we can say that t2 will be equal to 2 pi square root of m plus 2 divided by k. T2 is now 3, so this becomes 2 pi square root of m plus 2 divided by k. So we can write this as 3bi upon 2 pi square root of m plus 2 divided by k. From here we can say that our m plus 2 is equal to 9 by 4 pi square multiplied by k. This is our equation number 2. So from equation 1 and 2, we know substituting value of m from equation 1 into equation 2. We can write it from equation 1 and 2. We get k upon pi square plus 2 is equal to 9 upon 4 pi square, and this can be written as 9k upon 4 pi square minus k upon pi square is equal to 2. So we are going to solve it now, and we can write that 2 is equal to, we can take k upon pi square as common, so this becomes 9 upon 4 minus 1, which comes as k upon 5 square multiplied by 5 by 4. From this we can find out value of k. K will be equal to 2 into 4 into pi square divided by 5, which gives us 8 pi square upon 5. So we found out value of k. Now we are going to use equation number 1, substitute value of k and get the mass. So you can say from equation 1 we get m is equal to k upon pi square. Substituting value of k, we get m is equal to 8 pi square upon 5 divided by pi square, and pi square cancels out, so this will be equal to 8 upon 5. So we can say mass m is equal to 1.6 kg. So this is the initial mass m. This is initial mass m. Okay. So this completes the question. Thank you.